Okay, let's get started. So how about we go over the test, unless you don't want to. Should we go over the test?
Do it.
What's that? I heard a beep and somebody say something, but I didn't.
I said, let's do it. My fire alarm's going off. Sorry about
Oh, okay. That's okay. All right, well, I guess we'll go over the test. So problem number one. So number one, we are given a characteristic equation of s fourth plus s cubed plus 3s squared plus 2s plus 2. And the question was, determine the number of roots in the right-hand half plane. All right. So a couple things about that. I never said you were required to show Routh-Hurwitz. So you could have used your calculator and used solve or C-solve to get the answer. You could have also used MATLAB and the roots finding function to go ahead and do that. Let's go ahead and do Routh-Hurwitz and see if we can come up with that. All right, so the first thing in the Routh-Hurwitz is we identify the highest order S row, and then we work from there. Highest order S row is S to the fourth, S cubed, S squared, S to the first, and S to the 0. And that is our first sort of column of what we're trying to calculate. Then we start to fill in. Then we alternate. We have 1, 3, and 2. And I'm just giving myself lots of room so I can do the calculation here. 1, 2, and 0. And so what I did is I just alternated my coefficients to go ahead and get the first 2 rows. Now, to solve for the coefficients beyond, I have to use that determinant approach. So it's -1 all over here. And it's the determinant of 1, 3, 1, 2, which is equal to -1 times 2 minus 3, which should be equal to +1. Right? That's that first one. And then the next one over here is going to be -1 over 1. So I'm still doing that side. Or I'm still doing the first column because that's the one that I was always above it. And then I go to the 1 to the right times the determinant 1, 1, 2, 0. That's equal to -1 times 0 minus 2, or equals +2. Okay. And anything beyond that's going to be 0. So we're going to move to the next row. So moving down a row, now I'm going to use the previous 2 rows to go ahead and do the determinant approach. So this is -1 over a +1. The determinant is 1, 1, and 2, 2, which is equal to -1 times 2 minus 2, which is equal to 0. That's my first step. My next step is -1 over 1 times the determinant of, let's see, 1, 1, and 2, 0. Which is equal to, or 2, 2, sorry, not 2, 0, apologize. I gotta grab that one, which is equal to -1 times 2 minus 2, which is equal to 0. And so this is where people made some, perhaps a mistake or two when doing this. Remember, there were 3 conditions where we would terminate early. One of them is if there's an if there's a 0 in the first column. But a higher, sort of precedence is if you have a row of zeros. This is a row here, so I can't substitute E for that first element. I have to use the approach when I end up with a row of zeros. So I can use my auxiliary equation, A of S, and how I get my auxiliary equation is I use the coefficients from the row previous that. So 1 and 2, so that becomes S squared plus 2. And then I take the derivative of A of S with respect to S, and I end up with 2 and S there. So this term becomes a 2, and it still stays a 0 for that last term because 2S plus 0 is just the 2 and 0 term. And then I can continue on from here. So now this is minus 1 over 1 times my determinant 1, 2. And over here, it is 2, 0, which is equal to minus 1 times, I have that right? Hold on. Yeah, minus 1 times 1 or 0, I should say, minus 4, which is equal to positive 4. So for highlighting it in my first row, I have, or first column, I have 1, 1, 1, 2, and 4. So the question on the table is, how many sign changes in the first row?
None.
0 sign changes. So there are no right-hand half poles. Let's check that with MATLAB. So I'm going to use my roots here. And I'm just going to use the coefficients. 1, 1, 3, 2, whoops. Off by one number. 3, 2, 2. Okay, so how many roots here are in the right-hand half plane? How many roots?
None of them.
None, yeah. If I plot those, I have plus or minus j square root of 2. And the other one is 0.5 plus or minus 0.86 or minus 0.5. Sorry about that. So, let's say over here and over here. So minus 5 plus j 0.87 and minus 0.5 minus j 0.87. Are there any poles in the right-hand half plane? There are none. Some people said, and they did the roots correctly, they said there are 2. There are none. J omega axis poles does not mean you have poles on the 0 axis. I mean, in the right-hand half axis. And that was it for number 1. Questions on number 1. Fair, not fair?
Fair.
Okay, do you feel like you're prepared and there's reasonable expectation? Oh, it's very quiet.
Yeah, I thought that one was pretty self-explanatory, and we did that homework on it. So, and the fact that you didn't specify which method you use. So,
Okay. All right, let's go to number 2. So number 2, and I'll just go ahead and I'll do a screenshot here. I can bring that over so we can see it. Okay. All right, so this is a system where I said K is equal to 4. go ahead and specify P so that we have 5% overshoot. And T sub S, my settling time, is less than or equal to 4 seconds. So the first thing I need to do is I need to figure out what does the system transfer function look like and see if I can even have, or even have to do any calculations, because it might not even be an overdamped system. It could be that it's, I mean, if it's an underdamped system, it could be overdamped or critically damped. We don't know. So the first thing I'm going to do is I'm going to find the closed loop transfer function. So my closed loop transfer function is G of S. Actually, let's just go ahead and immediately substitute in 4. We don't need to make it difficult. We'll put in 4 over S times S plus P, all over 1 plus GS. And when we put this under, we invert and multiply, we're going to have S squared plus PS plus 4 is our closed loop transfer function. For a second order system, I don't care about the numerator, but the denominator should have the shape of S squared plus 2 zeta omega sub n S plus omega sub n squared is the format. So immediately we can go ahead and solve for omega sub n. So that's equal 4. So omega sub n, oops. Omega sub n is equal to 2. Right? And let's see. I have that correct. Let me just double check. Yeah, so now my P value here, my P is going to be equal to 2 times zeta times omega sub n. So I have omega sub n here. I need to solve for zeta. So my zeta equation I'm going to get for my percent overshoot equation is going to be equal to 100 e to the minus pi zeta over the square root of 1 minus zeta squared. If you solve that for zeta, you would get zeta has to be greater than or equal to 0.69 when your overshoot was going to be 5% or, whoop, what happened there? Your overshoot was going to be less than or equal to 5%. And then when you plug that in here, is equal to 2 times 0.69 times 2, I ended up with 2.76. Now that's the first characteristic to make sure that I'm going to have a less than 5% overshoot. The next thing I need to do is make sure that my settling time is less than 5% or 4 seconds. So my settling time for 2% is 4 over zeta times omega sub n. So if my first criteria is 5% overshoot, my second one, I have to verify that it's going to be less than or equal to my 4 seconds. So 4 over 0.69 times 2 is equal to 2.9 seconds, which is in fact less than 4 seconds. So there are 2 limiting criteria here. The first criteria is the 5% overshoot. The second criteria is the settling time. And with a P equal to 2.76, I'm going to meet the 5% overshoot, and I'm going to meet the 4% settling criteria. Questions on that? Am I going too fast? All right, is that fair, unfair?
Can you go over the settling time again?
Yep. Settling time equation for 2% is that your settling time calculation is 4 divided by zeta times omega sub n. So all you needed to do, because at this point you had your value of zeta and you had your value of omega sub n. So all you needed to do was to make sure that these values here resulted in a settling time less than 4 seconds. So we picked our initial value of zeta of 0.69 based on 5%. If that was going to be, if it wasn't going to settle for us, then we would have had to increase our value of P to meet that second criteria. So I just went ahead and calculated the 5% settling time zeta, and then I confirmed that my settling time was less than 4%. So I got my P value from the settling time, and then I just checked it with this equation here. That's all I did. You could have tried the other way around, but if you had gone through and you had said, all right, well, let's do my settling time first. My settling time is 4 over zeta times 2, and that has to be less than or equal to 4, which means that zeta would have to be less than or equal to 4 over, what am I doing wrong here? I did this correctly. Let's see. 4. Okay. Yes, no, I'm correct. 4 times 2. All this says, well, no, that can't be right. It's going to be greater than. I think I'm doing this backwards. So it's 1/2, which would imply, but I know it's less than 4 seconds. What's wrong with my math? Let me just do this again. So my settling time is equal to 2 over zeta with those values. And that has to be less than or equal to 4. So oh, sorry, I did this backward. Yeah, so zeta has to be greater than or equal to 0.5. So I did it correctly. I did it, I didn't switch it around. This has to be greater than or equal to. So all this would tell me is that it has to be greater than 0.5, but I still would have had to go back here and do the calculation to get the settling time. So you could have done it either way. You just would have, had to do it. You had to do this equation anyway. Or for this one, I just said, I'll usually start off with a settling time, and then I check my settling time. If it wasn't sufficient, I would have continued to increase my zeta until I met the criteria. Okay. I'm still looking to see, was this fair or unfair?
That was fair.
Okay. Did you all feel prepared for it? Was it unexpected? Anything tricky? Nothing. Here's your chance, because the way that I improve the tests is getting your feedback. And if you don't provide feedback, then I assume that nobody had any issues with it. So I'm not trying to force you to answer. I just want to make sure that you're getting what you expect to be a test that checks your competency, and understanding of the material, but is not overly difficult or getting you to trick you or anything like that. All right, well, let's proceed onward. Item number 3. So given my characteristic equation, s to the 5th plus 3s to the 4th plus 2s squared plus 7s plus k was find the value of k that results in a stable system. So this one you can't use your calculator because you're looking for a value of k that will result in a stable system. So I'm going to go ahead and start doing my terms. So I have row s to the 5th, s to the 4th, s cubed, s squared, s to the 1, and then s to the 0. And now I'm going to grab my s to the 5th coefficient. That's my 1. I need to go to the s cubed coefficient. There's no s cubed coefficient, so I'm going to put a 0 in here. And then I'm going to go to the s to the 1 coefficient, which is 7. Move down a row. I'm going to go to 3, which is my s to the 4th. Now I'm going to go to my s squared term, which is 2, and my s to the 0 term, which is k. So now I'm going to go ahead and do the algorithm. So -1/3 times the determinant, 1, 3, 0, 2. That equals -1/3 times, let's see, we have 2 minus 0 is equal to -2/3. I'm done. I don't have to go any further. Why don't I have to get any further? Because -2/3, what will I do to k to make -2/3 become a positive number? How can I adjust k?
Doesn't matter what you do to it.
Exactly. There's nothing I can do to k to make -2/3 become a positive number. If it was -2/3 plus k, then you've got some wiggle room to go ahead and make it change. But it's just -2/3. So you're done. Don't even continue to do it. So no value or no range for k. That's it. Fair, unfair?
Did we ever do any homeworks or problems in class where we ran into this?
That the value of k.
Yeah, not we're it having no range. System.
I don't recall if we did it where we wouldn't have a value of k. But why would that matter? That this is even easier, right? You can see that whatever you do to k, how do you make -2/3 be greater than 0? Remember, every term has to be greater than 0. So what can I do here to make sure that these are all positive numbers? Can you do anything?
No.
So I remember we did a bunch of problems with some values of k, and I think in the study session, we did one when we had a pretty limited range of k. This one is, it doesn't matter the value of k.
I personally appreciated that.
Good. So was this a reasonable question or? Everybody being very coy?
I think so, but that's just me.
Okay. I wasn't trying to trip people up. I really was like, well, here's a way to simplify it a little bit so you didn't have to dig around. I'm trying to make it a more straightforward problem. All right. Number 4. So number 4, we have a block diagram problem. And if you look here, we have a negative feedback system over here. So taking that part and putting it together is G1 over 1 plus G1, G3. That's the block that's in there. So I'm going to go ahead and build it back. G1 over 1 plus G1, G3. Then I have this in cascade with G2. This is a feedback of G4. This is plus minus. This is G5. So these two in cascade means they just multiply together. So I'm going to multiply those together and put that back in that feedback path. So that becomes, no, actually, let me do it over here before I put it in. So that becomes G1, G2 over 1 plus G1, G3 all over 1 plus G1, G2, G4 over G1, G3. Oh, sorry, 1 plus that, right? Plus GH. Okay. So now, wait a minute. So this is G over 1 plus GH. Yeah, okay, so now I'm going to put it under a common denominator. So that becomes G1, G2, all over 1 plus G1, G3, plus G1, G2, G5. That's that block, so that's what belongs in here. G1, G2, over 1 plus G1, G3, plus G1, G2, G4. And then I run that into cascade. G5. And then my final closed loop transfer function, G1, G2, G5, all over 1 plus G1, G3, plus G1, G2, G4. Questions on that? Fair, not fair?
Fair.
Okay. All right, last problem, which is number 5. We're given a transfer function, our T of S is equal to 2 over S squared plus 2S plus 4. That is in our standard form. I don't care what the numerator is. S squared plus 2 zeta omega sub n S plus omega sub n squared. So immediately I see that omega sub n squared is equal to 4. Omega sub n equals 2. And 2 zeta omega sub n equals 2. So zeta is going to be equal to 2 over 2 times omega sub n, which is 1/2. And then my last one, which is omega sub d, is equal to omega sub n times the square root of 1 minus zeta squared. And I can't do that math on the top of my head. I don't have a calculating capability to do that. Fair, not fair?
I think that one was pretty fair.
Okay. That was a test. Overall, what did you think? Everybody fried and not giving any answers?
It might just be me personally, but I would maybe prefer Jesus Christ, prefer more
Whoop.
I don't know what happened there. Prefer a little bit more, like maybe a few more questions and them all being worth a little less. I know you were at least with, but that's just me.
Okay. So instead of having 5 problems, have 7 or 8 problems.
Yeah, maybe I'm in the minority, but it seemed like each problem being, a little less stakes on it, gives you, maybe a little less stressful, but
Anybody else share that opinion? Very quiet. Does anybody want to know what the average is?
Yes.
The average was 85. So I generally thought people did really well. It seemed like material, most people did mostly got the material, most of it. Few math mistakes is what people got some points off, but for the most part, I think people did, did pretty well based on, the material that we covered.
So for this time, did you add any points, like bonus points?
I think you could get 105 total points on the tests. Is that what you mean?
Yeah, because last time you said that you gave something like 20 points to everybody on top of what we did. That's why I'm just asking if you did the same thing this time.
Well, I generally don't give additional points. I give you an opportunity to earn points. If I feel like there's a little bit of additional learning that needs to occur. But in this one, it seemed like the average was really good. So it seems like everybody did pretty well. So they understood the concepts pretty well. So I didn't plan on doing it this time.
All right, thanks.
Sure. Anything else? Okay, well, you probably could tell my voice is getting worse and worse, so I think I'm gonna end class for today, and then hopefully next week we'll be able to start full stream on the next material, which is woodworker stuff. So unless you have anything else,
Sorry,
Oh.
Paul, I have a quick question.
yes.
I might be missing something, but for the homework due next week, it looks like we're missing pictures, possibly.
Let me look. I think somebody made that comment, and I thought, oh no, so the open loop, let me bring it up, just give me one moment. Make sure that I'm looking at the same one. Huh. That's odd. Right. I thought you might be right because So what printer? I'll have to figure that out because for some reason, well, I'll clean that up and then I will update the file accordingly. So I'll figure out what's going on, but thank you for that. I apologize. So I will
All right,
clean that
thank
up.
you.
Sure. All right, there's nothing else. Have a great day, everyone. Great weekend. See you next week, hopefully in person. Take care.
Thank you, Paul. Feel better.
Thank you.